Haven't even started and you're clapping, great. So, hey, so basically I have a fairly quick presentation about, hey, AWS is cool. So this is the history of a kind of old project, you know, by today's terms, it was before the bad thing happened a couple years ago, you know, it was about like 2018 or stuff like that. So, you know, no Gen AI and stuff like that. So real developer work. So anyway, let me talk about myself. So I've been with Ness for about 7, almost 8 years, but you know, we round down. Our practices team mainly specializes on short-term projects. And by short-term, I mean 3 to 6 months kind of deal. It's not like years when you're like sit and work on the same screwing thing and you're like, oh God, please kill me. So anyway, I like AWS. I'm proficient with automation on that. So, and because, you know, I do short-term projects, there's been a lot of different clients that I worked on, mainly fintech companies, you know, banks, financial institutions, and yada, yada. So we basically do, a lot of the time, we do lift and shift migrations. So, you know, there is a company that is like, oh, damn, our on-premise is very expensive, so let's move to cloud. And then 3 years later, they ask us like, hey, can we move back on-premise, please? So yeah, and I like to call myself, because of that, professional software janitor, you know, because we go clean up and make everything clean. So, yeah, text is not centered, that's why I moved that thing. So basically, let me give you a little bit about the summary of what I'm gonna be talking about is investigating the clients, and then I'll show you how not to do AWS accounts and how to do better AWS accounts, how not to do databases, and how, you know, we just burned everything, because that's always fun. The most important part is that a lot of companies are kind of scared of AWS because they hear like enormous bills, again, $100,000 a month, as you know, I just said. So yeah, and basically trying to understand what the client actually needs or wants and how we made things cheap. So let's start. So basically, first, you know, a company approaches us and says like, hey, we need some help, please help us. So a little bit about the client. So the project that they asked us to help was already in progress for 2 years. And the timeline for it was 3 months. So, you know, the company has spent 2 years developing this system and, well, basically the whole entire team have been dismissed because a new CTO appeared and was like, we'll make things better. And mainly because, you know, the cost of running AWS was around $100,000 per month, and that is not cool. And there was no standards for AWS development. So yeah, no unified landing zone, and I'll explain what those things are in a little bit. So, and yeah, the most amazing thing, you know, 100K per month, so no cost controls. So let's outline the problems that they have. First, this needs to be a quick done job and needs to be delivered in only 3 months. There is no centralized AWS infrastructure, so you know you have to go and figure out where are the accounts and where is everything and how are you even alive as a company. And yeah, AWS cost is too damn high. So let's talk a little bit about AWS accounts. So this is what we did for the discovery of it. So we started asking questions like, hey, do you guys have single sign-on so your developers or DevOps people or engineers can access the AWS accounts, you know, in a more generic way than putting a username and password into AWS console? Do you guys know where you're spending money on? You know, and things like that. And how do you pay for the bills? Because again, it's 100K, so do you know why are you paying that and stuff like that? And you know, like, do people even report what they are using their AWS accounts for or not? And you know, they don't have an SSO. They have no idea what they are spending money on. And how do you pay for the bills? Well, I mean, we just get emails and we just pay for them. You know, we have money, we're a financial company, so, you know, we have loads of cash. And, you know, like, yeah, of course they don't report anything. So, yeah, let's talk about more detailed things and, you know, how the AWS accounts were structured. So, you know, first thing we found that all the AWS accounts, well, majority of them were registered on personal emails. So, you know, it's not a company, it's just gmail.com, you know, and you're like, great. Then, you know, Bob just sends an email, hey, hi, that's my AWS costs, pay. And yeah, the best thing, Bob no longer works at the company. So, you know, how do you know all of those things? And yeah, it was like something like 10 AWS accounts. And yeah, only 2 of them, I think it was like the recent ones when, you know, they started to think that, hey, I think we're doing something wrong. They didn't really grasp what they are doing wrong, but, you know, they had a goodwill. So then again, that's not the end. So then, you know, we started looking at what the hell there are in those AWS accounts. And, you know, hey, you know, there is an EC2 with public internet access, you know, exposed ports. And, you know, then, you know, we just logged into the machine using like Session Manager, which apparently they did set up. And, you know, we see that the root account password, you know, you go to SSH and there's like, yeah, permit root account. So, yeah, and then basically the IAM instance profile was allow everything, do whatever you want in the AWS account. Because like, why not? Why bother doing least access privileges where you can just slap a star and be good? You know, everything will work, no problems whatsoever. And yeah, why not run it on the Minecraft server? Because, you know, my boys need to play. You know, LAN parties at work, anyone, you know? So yeah, basically, this is what happened. You know, then we went on to other AWS regions, and we found just random EC2 instance modules. And, you know, yeah, they existed in different regions, 100% CPU usage. Wow, why? And yeah, basically then we were like looking at the trails, because we enabled CloudTrail, you know, auditing and stuff like that, because obviously, why would you enable that? So yeah, and they were like basically getting recreated every day. And you know, when we basically went into the system, we found mining. So Minecraft and mining, and you know, so why not? So basically, their whole AWS account was compromised, and it was running Bitcoin farming on it. And you know, 100K a month. I wonder how that happened. So yeah, let's talk a little bit about like best practices of AWS account infrastructure, because I know that was a little bit bad. So let's talk about what's good. So that's this thing can kind of depend on the company and the scale of the company, but this is like most generic sense. So you would basically have a very big AWS organization, and you would have only one root account that manages the billing. And then you would have, you know, your, I don't remember, like I think they changed the name of IAM Identity Center to something where it was SSO and now it's Identity Center. I don't know, they change the namings like every day. So basically, you have one big AWS organization that is managed by, you know, a central email that exists in the company. And you basically structure, you know, you have your root account that nothing happens at, only billing. You don't access it, it's only for billing. There is no anything, because you don't want to compromise your root account. And then, you know, there are service account and stuff like that, which basically, you know, a service account is something that links your entire AWS accounts together via like VPN, so your people can access from the office the AWS network, you know, transit gateways to interconnect your other accounts. And then again, that technically depends. Like we're talking when the accounts structure. So a lot of complex, like this is, we're talking probably like very big scale when you have your security teams really good at managing things and not just annoying you. And when, you know, your info security team is good, basically you would have an account per team, per environment. So, you know, you have your oh, we build UI stuff account, and then we have our other financial application A, B, and C, and you would basically have a set of AWS accounts that are also a part of organization. So you have an organization within an organization within an organization within an organization if you want. But basically, like, you can technically like do like, I don't know, another country office have their own organization and stuff like that. But basically, you know, you do the least access privilege and stuff like that. So you would have, you know, for dev, you would have developers having only access to that account. QA, again, sometimes developers. There are like cool new things that AWS did called like TPAM, like temporary access, something elevated thing where you basically press a button, manager approves your thing, and you have a temporary access to the account. That was new thing that I recently introduced, and it's really nice. I would suggest looking into it. But basically, why should you use centralized account structure? Everything you know about it. If you have a root account, you have an organization, you don't have random guys creating on their personal emails AWS accounts. And you know about everything. You can audit it, you can do whatever you want. And the most important thing, again, with the case of Bob, you know, Bob left company and bills are still coming to this email, and he's unreachable because, you know, he just quit the company, or like he got fired or whatever. He could be a rogue agent that gonna go and install, I don't know, not Minecraft, but I know whatever other game has server capabilities or whatever. Like, that guy still has access to that account. So you basically have multiple people, you know, you have your business emails that are like forwarding stuff and stuff like that. So you're not, how can I say it? Like, you're not limited or locked to one person being rogue or hit by a bus and you lose your entire worth of company. And yeah, basically one root account, because again, centralized things. And there is a lot of AWS tooling that can restrict permissions and grant by least privilege, which I know is annoying. Like, when you know you just need another permission to access like some random service, and you have to go through hoops of security, like 20 different emails going back to a manager that goes to a manager that goes to a manager, etc. But least privilege is secure. So, and again, the most important thing is billing is centralized. You can see what accounts are using what, you can see what teams are spending in, and again, like sometimes if you have a rogue account or again something happened, you would see a spike in the bill and, you know, take actions. And yeah, that's basically it. So let's talk about the project, because right now we just talked blabber generic AWS things. So the client that we had fun with. So again, client is a financial company. They basically analyze stocks. They have their own business guys that do math, and you know, like, they basically process stock, mutual funds, ETFs, whatever, the other fancy words about financial things. And they have an Oracle database, which financial companies and legacy goes hand to hand. So they basically have an application that they detailed us that goes and into that Oracle database, processes some data and dumps it into a database in AWS, and then they need an API to access this data. So that's the description. I know it's short and kind of like vague, but we'll get to it. So let's talk about the history of the project. So it was spent already, as I said, 2 years, but again, you know how projects take over, it takes a little bit of time. So again, the actual development was 1.5 years already, and the product that they're currently migrating, because remember, they already had on-premise stuff and it worked on-premise. So their product on AWS was slower, and they spent 1.5 years working on that product. So the project was very tightly coupled with on-prem environment. So they basically had like workers that had to come into their Postgres database that then connects to Oracle somehow through like connectors and stuff like that. So you would never have like, if basically on-premise goes down, your AWS goes down and vice versa. So good luck. So yeah, the known costs about the project, we're not talking about Minecraft servers and Bitcoin miners, 30K a month. So they had like big things spun in there. And yeah, we have to clean this up in 3 months. So they did not have in those 1.5 years a QA or a prod environment. Basically everything dev, you know, we're making this faster, we'll make it, only 3 months. And obviously no automation, because why would you need automation? Be consistent with delivering something, you know, that you get consistent results every deployment. No, we'll just hack things in, you know. And yeah, database. Let's talk specifically about the database, because that was the most fun part of this thing. So basically they just, you know, where did this 30K come from? Big Postgres database. I don't remember the exact numbers, but again, there are like a lot, so like terabytes of memory and stuff like that, because, you know, work slow, more power and stuff like that. So anyway, it was running 24/7, so even when developers weren't around, you know, it's still costing money. They had a pipeline that actually worked and, you know, did some ETL on the data, and it took about 12 hours to complete. So basically, you know, when a business guy goes and like, hey, I need this data to be processed, they basically can just stop working and come next day and fetch their data. So yeah, and any data queries to the database took minutes or hours to complete. So again, business developers, you know, could just press enter on the query and go enjoy lunch. So that was fun. So, and that's one of the reasons. So let me talk about the database structure, how they managed to create it. So all of their data lived in one table. And I'll show you the examples, because those were the examples. So, you know, you would literally have all of the data in 4 columns. So, you know, you would have like external ID would be the ID of the company, and basically company A lives at sample street 1 and stuff like that. You know, this is whatever their market cap, and again, they are specializing in electronics and stuff like that. So one table to rule them all, right? And the way the data, the queries worked is they would have to fetch all of those rows and collect a proper column string. So, you know, you would get a company A, first column, second, you know, sample street, and with the column names. And basically for every column you had to fetch, you had to join, and join, and join, and join, and join, and join. And they had like 50 columns in their queries. So literally the query had 50 joins on the same table, so you would have to full scan it every time you run the thing. And look at this, there are no indexes, only the PK, and that's practically worthless. So yeah, and the size of it, 5 terabytes. So great, fun. No wonder it took like, you know, hours to complete a query. So let's talk about the problem and how we basically fix it. Thankfully, the client was in a dire state and they basically were not able to deliver the project in those 3 months. So, you know, they said, do whatever you want, we need this in 3 months. And this is why this is a miracle project, because you basically don't get a situation like that. Because the company got hacked, they basically fired all the IT team, and they just gave us a carte blanche and we could do whatever we want. So, and what we did, literally just remove everything. There was like a whole interesting conversation how we got rid of the AWS accounts, because again, they were on the personal emails and there's like a lot of things. But basically, you know, the reasons. AWS accounts were a mess. Postgres database is hosted on AWS, and because they didn't have any automation, we basically had to scratch everything and rebuild. No automation, because again, everything was just built and built and built as it goes, and no one, you know, XKDC has like great like Lego pieces, and there's like one thing that relies on everything that you break, and everything just breaks, and that's kind of thing. So again, the current state of the project was in the IT team of that client knowledge and hands, and as we talked about before, they were fired. So there's literally no one that could tell how that thing works. And again, we knew that AWS were exposed accounts. That was an interesting sentence. AWS accounts were exposed. So again, we can't trust that the AWS accounts are clear, because again, they could create things that circumvent certain things. So now again, let's talk about why AWS is not evil. When you shoot yourself into the knee and be surprised why our AWS bills are 100K. Well, again, the thing is, yes, AWS wants your money, obviously, because that's a company. But here's the thing, they don't want to spend all of your money. They want like a percentage, a good percentage, but again, not everything. Because again, if you spend everything, you'll just move to another cloud. You have Azure, you have GCP. No one really talks about GCP, but it exists. But anyway, like the thing is, one of the additional things, and this is again, because I worked at lift and shift projects, it sucks because you don't know the architecture a lot of the time. And a lot of knowledge in those applications that you need to lift and shift are like generational. You have generations of developers that are working on those products, and like they know everything, but they can't say what it's actually doing because they spent years and years perfecting this product, and they just have it burned in their brain. And when you ask, well, it's simple. It just, and your brain just goes, yeah, I understood some of those words that are, commas in your sentence. So again, this is what we're working with. Again, remembering the centralized AWS infrastructure, we need to have landing zones. And again, that's kind of like centralized AWS landing zone. So the service account is like part of the landing zone because you land into AWS that way. So yeah, let's talk about, again, understanding what client wants. Really wish I had some water with me. So on-prem database doesn't go. They need on-prem database because, again, a lot of historical data, years of data. Again, 100 terabytes. It's very expensive to run a 100 terabyte database. And again, storage-wise, not RAM-wise. RAM-wise, it's pretty impossible unless you have, I don't know, an IBM supercomputer. But yeah, so project actually needs only a handful of data. Because remember, in Postgres, it was 5 terabytes. It's still a handful of data, but that's 5% of the data. So, but really it needed a lot less. And we'll show some examples. So we need ETL, and we need to run it once a month in the worst case scenario. So everything goes good. There are no, like, I don't know, GME stock rising and getting insane amount of money from it by shorting and stuff like that. So in ideal case, it needs to be run only once a month. And we don't want to pay for, a whole month of being still active but not being used. So, and again, API that serves data from AWS database, only read-only. There are no like ingesting API calls where, like, hey, update me a client or whatever. It's only strictly read-only. So again, and they want a better AWS structure, so the Minecraft 2.0 doesn't happen. And obviously, ideally, some automation, like just a little bit. Compared to zero, everything is infinite. So the most important thing needs to be cheap because they already spent an insane amount of money on this project, and day by day, the more we are in discussion with clients or what we're gonna do, they are still spending money that they could have paid us instead of AWS. So again, what we're gonna do? So basically, least access roles AWS organization. Again, provide only things that are needed for developers. Don't give developer access to prod because this is how you break production in your company. Then, again, accounts should exist in the AWS organization because you then can lose them if they don't exist in the AWS organization. Again, policies, and this is a good thing about AWS organization, you can literally like do an account-wide SCP policies. whatever they called. And basically you can say like, no, you can only spin like T2 large machines with like 4 cores and like up to 8 gigs. You can specifically limit the machines that are spin up. So again, cheap cost control and stuff like that. Again, we love Terraform. I particularly hate Terraform in a lot of places. I have like a love and hate relationship, especially when you get to like counts when you need some infrastructure, but not everything. And you just like, I hate how they did it. Thankfully, AWS CDK is great. But anyway, that was before the AWS CDK and stuff like that. So we decided to go with Terraform because again, we needed a consistent, reproducible result. We needed something that you can tear down, bring back, tear down, bring back, no changes, all good. And yes, I know some of the people could fear Jenkins because it's obsolete, but remember that was like 2019 and stuff like that. There was no GitLab, GitHub, whatever, this 100 CI/CDs stuff. It was just Jenkins. Jenkins was great. So, ETL. The most important thing, we needed to process the data from on-prem and to a new database that we're gonna be spinning up, and we just glued it together using AWS Glue. Some laughs? A little? Okay, fine. So anyway, let's glue it all. Basically, AWS Glue is a really fun thing. It's basically PySpark and Spark. You can do a lot of cool things with it. If you know Spark, and basically you need to learn either Scala or Python, because PySpark is cool. Probably there are some libraries that are working with Spark, but those were the most prominent at the time. So yeah, automated. We need everything automated. So we have Oracle, we have Glue, and for this project we decided to go with Aurora and specifically MySQL. Because MySQL is cool and Aurora is AWS and we are in AWS environment. And the cool thing about Aurora is it can scale. There are like serverless variants that can basically scale to 0 and not cost any money, or they can scale to insane amounts with 20 hundreds of read replicas that happen like inside of them. And you know, like just again S3 to host and store those files, because basically our like MySQL and API would like fetch information and store it for historical purposes into the S3. Because again, the thing is, we talked about it, it is read-only and there is only small amounts of historical data that is needed. So yeah, again, just simple, small database. Again, you can scale it down, and then API gateway, because again, you don't really need like an EC2 instance to host your API code. You can go serverless. Those fancy words and stuff like that. And clients had to have authentication, because this would be an endpoint for the clients. They would actually be using, you know, the API gateway to fetch information from the database. So we went with Cognito. And then again, to save costs, you can just glacier your data. We really rarely need historical data for this client, so it could literally go into the deepest hell of Glacier. And then they specifically were fine with taking multiple weeks to get this data, because again, anything that's basically a year old can take more than a week to take out. So they were fine with cost savings, and Glacier, very inexpensive. So again, let's talk a little bit about why, even though I already talked about it. So Glue, Spark is great. And we did not have a Java developers, you know, Java Spring Boot and stuff like that, Flink and stuff like that. So we were basically 3 developers. So yeah, 3 developers for the 3 months to build all of this infrastructure. I kind of forgot to talk about that. So yeah, and then again, PySpark is great, and can do the same thing as normal Spark, but again, with added benefit of pandas. And you know, if there are any Python developers, they probably know about pandas and how great it is. Just literally just plop some things in, you know, 10 lines of code, and it processes millions of rows that otherwise it probably was millions of rows in Java. So again, the additional benefit is that Glue is serverless. You are paying only for the jobs. You don't pay for big entire Spark cluster that needs to exist for eternity, and then you run one single job in it. So again, it's distributed, and again, the good thing, again, pandas and PySpark, you can just parallelize it, and again, it can be scaled quite much. So at the time of that, it was like 1,000 DPUs, but I think at this moment they have like increased the limits on the Spark clusters. But again, 4,000 TPUs and a lot of data. So yeah, fun. And the really good thing is it's hard to debug Spark, but they have like a debug endpoint that you really can just debug, place like open PyCharm, connect your glue endpoint, and then just debug code line by line. Aurora, dynamic storage, that's also like actually a really good thing that I kind of forgot. Again, at the time when that was created, so again, 5 years ago at this point, oh God, how time flies. So yeah, limited storage, and you couldn't just like create MySQL with like 10 gigs and then extend it. You literally had to like redeploy the database, which kind of sucked. There was like a lot of problems with it at the time. Again, now it's all fixed, and probably like by the time that we finished that project, everything was good. But basically, there is dynamic storage with Aurora, so you can, again, whatever the data you put, it just automatically scales. Again, sometimes we could have basically a scale event when a lot of clients fetching the information, so we could just scale up the read replicas. And again, Aurora is very deeply integrated with AWS. There is a lot of like stored procedures and stuff like that. Again, you could literally just S3 dump into a database and vice versa with like a bunch of inbuilt tools and IAM permissions. Again, technically that was improved already. Like if you look at AWS right now, you know, your RDSs already have like built-in IAM stuff, but it wasn't the case like that at the time. And this is what was very important. I don't know if that's, again, still the case, but I think it is. Read performance is a must for us. And right now, at that time, Aurora was basically very good at reading. And we really literally needed to only like write occasionally to it. So, Cognito. It has a built-in functionality with API gateway, so you don't have to write your own authentication. You can just use whatever. And again, plug and play, serverless, whatever, just press a magic button and 5 lines of Python and you're good. The case for the project, again, that doesn't scale for everyone, but for us, it wasn't a lot of requests of client, because they would normally like, again, fetch at the start of the month, and there was like maybe 10,000 requests a day or something like that. So it was like a really small amount. So the costs for us were negligible. And again, Terraform is good. You can just automate everything. The gateway. So that's just a cool thing about Python is we could, because we were using PySpark, we could just use the same data bindings between just our AWS Lambdas and our PySpark with PyAlchemy. And it was really cool. It has like a bunch of migrations. You can go up, you can go down, and basically ORM and stuff like that. Again, it's serverless, so if you don't use it, you don't pay for it. Again, with an asterisk and stuff like that. But again, for our specific use case, and again, that's a miracle scenario, it was basically like no money. And yeah, the good thing is because we were constantly iterating on how API works and stuff like that, we could just do stages, and you know, like we have a dev QA stage, we have a UAT stage. By the time we were like at one account, because we had like other people prepare us AWS accounts, so we could just serve from one API gateway different versions of the API. And again, Cognito auth is very easy. Like press a couple buttons and you have authentication. So Terraform, again, good. The best thing about Terraform, again, comparing to the CloudFormation of 2018-19, is very robust state management. Like even now, CloudFormation drifts occasionally. Like someone goes in and changes something and everything breaks and you're like, oh God, I need to like destroy this stack, but there is like a rollback. So I need to like go and manually do very awkward things. And with Terraform, you can still screw it up, but it's a lot harder. Again, declarative. So that was a benefit for us because we will be giving this code to a newly born IT team of that company. So we needed something declarative that doesn't have like 20 different if statements and stuff like that. So again, you just have it in a declarative way, and it was fairly small. Modular, you can do modules, and the only very annoying thing that I have with Terraform is designing API gateways is a pain. I don't know if anyone ever did it, but good luck. It's painful. And yeah, the really good thing is you don't have to delete everything. Again, it's stateful, so it will see something and it will say like, hey, you need to redeploy only this thing, not everything. And one good thing is, again, well, technically doesn't compare to like CloudFormation, but again, some people use things like Ansible as their code think tool. But you can just have a remote state, so multiple developers can access the same state and not break each other's hands when deploying the same things with the same prefixes and stuff. So again, how we got from 100 grand to small amount. Basically, needs everything scalable. Basically, again, RDS can be scaled, API gateway can be scaled. You know, RDS for our thing, the RDS was like less than a gig. So again, 100 terabytes of data that was on premise. The guys that had previously in the client IT team made it to 5 terabytes, and we had only 1 gigabyte. So that was very efficient and fully qualified their needs. So again, for RDS, basically what was done is, you know, first month or first day of the month, we scale it up, make it big, run a big ETL. I think we had like 500 CPUs and like a bunch of terabytes of memory, and it was like chugging along for about 15 minutes. Again, compared to hours and hours and days, the old process. Yeah, and again, the most important thing is, again, the guys before was thinking about that storage is expensive. Storage is not expensive. Like if there are some people that think like that, it's a lot more cheaper than paying for CPU power. Because again, with Postgres, you know, you would have to do all of those beautiful joins. And it would be CPU power, not just storage. Basically, we had a lot of duplicated data in our ETL process, so it's easier to read and you don't have to do complex joins across the data. So sometimes it's fine to do duplicates, because again, for our use case, there was only once a time, like once in a while approach to dump the data, and it was read-only. It was not changeable. So again, one of the things that is just generic is if you need to have like a static EC2 infrastructure or RDSs or CS clusters, just pay for reserved instances. Like if you know that this project will be a lengthy one, just pay for the reserved instances. Like you know that you're gonna be spending 5 years on this project. Just pay like 3 years up front. You get like a lot of discounts like that. And in terms of big projects, AWS will subsidize a lot of your development if you're reaching out to proper companies. Like I think right now the project that I'm currently in is about like 90% discounts on the whole infrastructure for development. So again, it's a pretty nice thing. So basically AWS eats those costs so you can be expensive initially, and then they will even help you with subsidizing and like helping with sometimes even developer resources that, hey, you can do this, hey, you can do this kind of thing. Again, serverless, if you can. Obviously, again, it doesn't apply for everyone, but again, if you're not using the product, don't pay for it. So in our use case, again, it only costs when the lambdas are run and it wasn't that frequent and stuff like that. And again, Glue was really cool. Like again, you would not be able to do that again like 10 years ago. You know, you would have to spin up your own prem Spark cluster, and now you press a button, something in cloud happens, and you have a working PySpark cluster, and you just press a button and it shut down, and you don't pay for it. So that's great. So yeah, we're getting to the end. Basically, final notes. Again, if your infrastructure can be serverless, and this is, again, doesn't really apply for a lot of lift and shift migrations, because a lot of times clients have like very old products, and they're kind of adamant to not move to a new process and stuff like that. But if you can convince management team that, you know, hey, let's not pay for things that we don't need, then again, you can use cloud in a cheap way and make sure it's serverless. Again, doesn't apply to everything, but use as much serverless stuff as you can, and understand that sometimes serverless could be more expensive. This is also like a thing to note, that depending on the amount of throughput or the amount of bandwidth, amount of GPU stuff, serverless doesn't scale really good in terms of costs. It can help you with being infinitely scalable, but it still kind of boils down to sometimes you would have a server, not less, but server full thing. Again, AWS costs bite you when you use AWS recklessly. Again, spinning up Minecraft servers. And speaking of Minecraft servers, never create personal AWS accounts and use them at the company. And I know that some people, even at my company, was like, well, I'm using it for dev and it doesn't matter, you know, like for his like testing and stuff, like he's prototyping something. No, if you're prototyping for a company, make company pay for your account or even something, again, so it's not lost and stuff like that. Again, if you're doing work for a company needs to provide you. So yeah, and again, same thing. Gaming is cool, but again, don't use company resources, it's vice versa. Yeah, sometimes it's fine to have a Phoenix. Sometimes you need to burn everything. So yeah, that's about it. Now shoot me questions, you were first.